the symbols in that. It was just kind of a little bit of a review of the symbols and when we do what. And then we identified a left-tailed test. And remember, the tails and the shading is based on the alternative, because we're testing the alternative against the null. Remember, the null is a statement of equality, and the null is the status quo. So we're always testing against that, which is what I wrote right there, testing the alternative to the null. All right, so at the top of the next page, so our alternative down here, we have less than, greater than, and the only other option is not equal to. So we can have our null hypothesis be, the mean is, really, let's do it like that. Our null hypothesis, the mean is equal to k. The alternative hypothesis would be the mean is not equal to k. So if the mean is not equal to k, then that means you have what's called a two-tailed test. Where these shaded regions are where your test statistic lies.
Wouldn't it be like just like paint one off on each side, like depending on what number it was, like what number k was? You know what I mean? Like there's so much space in between the middle there.
Well, that's just my drawing.
Okay, but like if like.
Oh, you mean because we're not. Explain why you're.
It can be less than, and then it can be greater than, but it's not equal to. And if it was like 5, then it could be 4.9, it could be 5.1, and then that line would be the other thing that's. Yes, but remember that we're testing things inside of a confidence interval. So we're not testing an exact value. Okay. We're going to test in a range. We're going to say, yeah, it's somewhere around here, and if it's not, it's out here. So. But that's just my drawing. The test region could be much more shaded, or less shaded for that matter, but probably more shaded than that. But I mean about that. All right, so let's go through the 7 steps to perform the hypothesis test. So you're going to do what we were doing yesterday. The first thing you've got to do is state the claim mathematically. After you've stated the claim, you're going to identify and label your null hypothesis and your alternative hypothesis. Now, the next thing you're going to do is identify the significance level. And this goes to kind of the stuff we were talking about before with confidence interval. They'll assign a significance level in order for us to figure out that interval that Jabin was just talking about. So that we're not trying to test necessarily an exact value, but we're going to have a level of significance. And that is going to have a new letter that we have not encountered. Looks like a fish. That's alpha. That's lowercase alpha in the Greek alphabet. Well, it's like fish. And that's what we use to identify our significance level. Then you will sketch the standard distribution. So you're going to sketch this. I will try to remember to give you curves on things where you're going to have to shade and stuff. Sometimes I forget, but I'll try to remember to put them on there. But I won't ever label them for you, so you'll probably have to go in and label. But this is a standard distribution, which means the mean is always 0. I should put n up
is always 0, and these are our standard deviations. Because we're standardizing everything. All right. Then we are going to calculate the test statistic. Once you calculated your test statistic, you're then going to mark and shade your distribution. So wherever it happens to be and whatever kind of test it is, you're going to mark and shade. So I just shaded like it was a right-tailed test, just for example. Next. We're going to calculate what's called the p-value using either tables or technology. So, and when we say tables, it's either a Z table or a T table. And when we use technology, you use what it corresponds. You're either doing a normal CDF or a T, I can't remember what that called, the T one's called, but a T CDF is called, I can't remember. But when we, TCDF. So you're either doing a normal CDF or a TCDF if you're using technology, or you're using your tables. Then you get to make a decision. And this little graphic organizer is going to help you. You are going to compare your p-value to alpha. If the p-value is less than or equal to alpha, no it's not, then you fail to reject the null. If it is less than or equal to, you reject the null. And then you will interpret. All right. So this says state your hypothesis and identify your claim. Determine, I should say state your hypotheses, meaning both. State your hypotheses and identify your claim. Determine if the test is left-tailed, right-tailed, or two-tailed, and then state your potential type 1 and type 2 errors. So on number 6, the proportion of high school students who text while driving is 78%. So the proportion of high school students is 78. So P equals 0.78. Everybody okay so far?
Yes.
Which means what is my complement to that?
P does not equal 0.78.
P does not equal 0.78. And because the null hypothesis is always the statement of equality, then that means this is my null and this is my alternative hypothesis. Which means this time the claim is the null, or it is the status quo. So when we go to test, we're testing to see if the status quo holds true. Is it really 78%? So we're testing against it.
It's two-tailed.
It is a two-tailed test. Now, why could it be a two-tailed test? And this goes to what we were talking about when we did the illiteracy question.
It could be greater or less than.
Exactly, because it could be greater than 78%, or it could be less than. That's why it's a two-tailed test. All right, potential errors. Type 1. All right, so type 1,
If it is 78%,
It is 0.78, but we would check it.
right.
And the type 2 is.
It is 78%, but we reject. Type 2,
It isn't.
right.
So it's percent.
so we go with
But we do not reject.
once I'm ahead of you on writing something, this one is crazy.
All right, everybody good? So far, so good? All right. So try number 7.
Oh.
you can word it differently.
But is, okay, because I put
The reason I went ahead and worded it like that is because we can say all day long, accept it, reject it, accept it, reject it, because we're stating the words on the table. But do you really know what that means? Like, if we accept it or reject it. So that's why I wrote it like that, because if the mean is greater than 2 years, and we reject that, then what we're saying is that the actual mean is greater than 2 years, but somehow when we tested it, we concluded that it wasn't greater than 2 years. So I'm just trying to like make it where the actual scenario makes sense.
Why is it greater than instead of less than?
So we don't know if we.
Because remember, you always go off the null, and the null is the statement of equality. And this time, the null happens to be the complement.
Be greater than or equal to?
Yeah, because it's equal to. Because it has to have the null has to have the statement of equality in it. All right, number 8.
ooh, I don't know.
Okay.
I did not like that. You got me.
right, y'all okay?
Yeah,
No trouble yet, right?
it's making more sense.
Okay.
now.
All right. Okay, so let me turn this off. So what we're doing right now, it is just, I'm not going to have you write out the